Hi guys! So you have been learning about Alfred Wagner and continental drift, and one of the pieces of evidence that he used to prove his theory was the rocks and fossils that he found on different continents that are separated by oceans. So obviously he didn't just walk to a continent or travel to a continent and pick up a rock and look at it and say, oh hey look, a rock. It looks like something I saw on another continent. What he had to study was the actual rock layers that were embedded inside the earth, and he had to look at the fossils that were found in those rock layers. So we're going to do an activity where we take these 4 outcrops. So we have 4 different sections of rock that have been taken from different places around the world. You can see that they have similar types of rocks. In order to know what type of rock I'm looking at the colors and I'm looking at the patterns on them. So I see this reddish color has dashes and dots. This green color has all dots on it. Yellow has big circles in it, which would be like big stones or rocks. Oops, my pieces are falling already. The blue has just dashes in it. The brown looks like a brick wall. So each of these different types of rocks have a different name. So you can see I have them labeled. So we have conglomerate, fine sandstone, coarse sandstone, siltstone, limestone, dark shale, and light shale. So we're going to use these pieces to construct what the full picture would look like from the very first layer, the oldest layer of rock, to the youngest, newest layer of rock. All right, so inside of each of these layers, we have symbols. So I can see circles and squares, I can see some triangles, I see curlicues. Over here I see X's, I see diamonds, I see rectangles. So those symbols represent the fossils, which are the index fossils. Remember we said in our reading passage that index fossils were fossils of living things that were only around for a certain period of time on Earth's history. So they allow us to know exactly how old that rock layer is because they were only around for a certain time period. So we're going to look at these and try to stack or combine all of these layers into one big geological column, with the oldest layer being at the bottom, the youngest layer being at the top. My pieces keep falling off the wall, just ignore that for now. All right, so when I look at this, in order to figure out which layer is the oldest, I have to look at the fossils. So when I look at the fossils, I'm looking for a fossil in one of these layers that I only see in that layer and no other layer. So when I'm looking at these different outcrops, I see circles in a lot of different layers. I see squares in different layers. I see the triangles in lots of different layers. I see the curlicues. I only see the curlicues here, but they're up near the top of a formation, so I'm going to guess it's not the oldest, since the oldest would be at the bottom. Over here, I see diamonds, I see X's. I notice the rectangles. The rectangles are only found in that one layer of rock and nowhere else. So I'm going to use that as my starting layer. So I'm going to take and pull these pieces down so I have a space to work. So notice that outcrop 3, I actually have it in 3 sections. There's a wavy line between some of these layers. That wavy line is what we call an unconformity. An unconformity means that something happened to the formation of this rock and we are missing rock layers here. All right, there's something that belongs between these layers. If my layers have a straight solid line, that means that it's a full layer, it's a complete layer. So I can see in this one here, something's missing here and something's missing here, but this is a full layer where these two meet. These two are full layers where they meet. Okay, so I'm going to pull those off and lay them down. Same thing here. I have a complete layer, and then I have that wavy line again, which means that there's something missing between these 2 layers. It could be a full layer of rock, it could just be a partial layer of rock. And then same thing here with my outcrop 1. So full layer, we have missing rock here, all right, and then it goes into the other ones. All right, so I'm going to use this as my starting piece because we said that the rectangles were only found in this layer. So we're going to place this at the bottom, all right? And I'm going to bit of tape just to make sure that this does not end up falling down on us while we're doing this. Alright, so I have conglomerate as my first layer of rock. It has the fossils of X's and rectangles. And then I have a layer of fine sandstone. So this conglomerate layer was complete because there's a straight line. Then I have my sandstone, my fine sandstone, and I see that it also has X's. So whatever this organism was, it lived during this time period and the time period that this rock was forming. So I'm going to look at all of my other pieces laying here on the floor, and I'm going to look for a piece that is the same type of rock and has the same type of fossils in it. So I see fossils that are the same, but this is coarse sandstone, so that's a different rock. Fossils are the same, but this is siltstone. It's a different type of rock. When I move to this piece over here, I look at this bottom section and I notice that it's the same rock. It's the fine sandstone. It also has the X's in it. So I'm going to take this piece here and I'm going to overlap it because there's a straight line here so that my two straight lines meet like this. And I'm going to overlap it. So now I have a complete layer of conglomerate, a complete layer of the fine sandstone. I have a complete layer of this green rock, which is the coarse sandstone. And then I have a layer of siltstone here. So I'm going to do the same thing again. I'm going to look at the pieces that I have, and I'm going to look for something that matches up with what's already here. So I don't have anything blue and brown yet. I do notice here that I have a piece that's the same red. It's got the same fossils in it. And I notice that this has two straight edges, which means it's a complete layer. So I think I'll use this piece next. I'm going to place it on top of this, lining up my straight edges with my straight edges. And again, I'm going to tape them just to make sure that we don't fall. Okay, so now we have conglomerate, fine sandstone, coarse sandstone, siltstone. We have two different shales here, a dark shale and a light shale. So they're both the same type of rock. There's just something a little bit different about them that makes one a darker color than the other. I know my colors look the same instead of being two different colors, but this is considered to be a dark shale and a light shale. All right. So now I'm looking at my pieces and I see we went from X's, they started to die out, and now we have diamonds coming alive in this time period. We have diamonds still here, but now triangles are starting to be alive. Notice there's no diamonds here, so triangles are the only living organism at that point. So when I'm looking at my pieces, again, I'm looking for a complete layer, okay, a complete layer. So what I notice when I look at all of this, I see this big piece over here has, go on this side over here, I see that it has the same fossils, the triangles, straight line, straight line. So I think that's what we'll go with next. So I'm going to line up my straight edges like this. I feel like we're not very straight anymore. Attach you there. Tape you to hold you. Okay. So now I can see that I've got a pretty good representation. I've still got some random pieces down here. Okay. So when I look at these, I notice I've got the green with the X's, the red with the X's, and the diamonds. We said that that was the same as this here. So what I'm going to do with this one is I'm going to line up the bottom of my red with the bottom of the red, like that, and just overlap it, because they're the same type of rock. Okay, and I notice this one here, I have the brown and the blue straight edges, so I'm just going to overlap them where the straight edges are at. Up near the top, I see that I have the yellow with triangles and the red with the triangles. So I'm going to overlap those at the straight edge. And then finally, we have the green with the squares and the red with the circles. So I'm going to overlap those at the straight edge. So now I have a geological column. I took all the rock samples. I matched them up based on the type of rock and the type of fossil that's found in them. And I can see I have 1, 2, 3, 4, 5, 6, because those are different, 7, 8, 9, 10, 11, 12 layers of rock. And that principle of superposition says that the oldest layers always form at the bottom. Your youngest layers are always going to form at the top. I can see when I look at this that the fossils, the first fossil was rectangles. Then we had X's. As the X's died out, diamonds became alive. Then we had triangles. Then we had the curlicues. Then we had squares. Notice the triangles lived during quite a bit of time here. Then we went to circles. Okay? So my rock types repeat. We've got fine sandstone again. We've got the siltstone. We've got more conglomerate. We've got more coarse sandstone. And we've got the siltstone up here. Okay? So when Wagner talked about finding rocks and fossils on different continents and using the age of the rocks to figure out that the continents at some point had to be connected to each other, this is what they were doing. They were looking at rock samples from different continents, looking at the type of rock, looking at the fossils in them, and able to figure out which layers formed at the same time. You're going to use this to build your own geological column in today's activity. So you will have all the same pieces that I started off with. You're going to rearrange them so that you get the same final product as this, and then you will have some questions to answer after.